Hello friends, welcome back to the latest video of StarProof. Up till now we have completed the analysis of single span as well as the continuous beam. Now in today's video we are going to discuss the analysis of a single bay frame structures. Right? So let's begin with that. So in the today's video we are going to analyze this single bay frame of A, B. At A and B fixed support is there. This A is the span is 5 meter and along B the span is 4 meter, get subjected to this UDL and then the point load. So let's begin with that. Select the next structure. So now as this is the first, so considering here the frame 1, next add beam, finished, select the front view. Now the first column is of 5 meter, so adding here a 5 meter, then next a horizontal span is of 1.53 meter and then the 4 meter. So here say 3 meter and then next 1, 2, 3 and 4 meter. Now let's switch off this grid view. Control plus N. So this node at 1 meter is additional node, so I just delete this node. Okay, now I add the beam over here between 1 to 3. So now here first to 3 the span is 5 meter, then next 3 to 4 the span is 3 meter and then next 4 to 5 the span is vertically it will be 4 meter, right? Node number 5, so here it is at a 1 meter height. Okay, means this will be the 4 meter. Okay, now next is in the general property. So define the properties considering again the rectangular section. Let's say the properties of 0.4 by 0.4 cross section size concrete, add over here, close. So assign to view, so it will be get assigned to all the members, right? Next go in the support, create the support. Now support is fixed, add over here. Now support 2 is add the node number 1 and 5, assign to the selected nodes, assign yes. Now here in the first span there is a uniformly distributed load of 35 kN per meter is there in the x direction and the point load again in y direction. Then here 25 kN and this load let's we take as a 15 kN. Okay, so let's start with that. Add the load definitions. So considering the load case details, add over here load case 1. Okay, close, selecting load case, add this. Now first I'm adding this nodal load. Now this load is a uniform force of 35 kN per meter, but now this will be acting in global x direction, right, in the positive x direction. Therefore I am considering here the gx. Add. Next there is a concentrated force acting of 25 kN in y direction, so considering that concentrated force that will be get added. Next again there is a nodal load of let's say 15 kN, but sorry that will be in x direction, that too in minus 15 kN. Add over here, close. Now here I am adding one more node at a distance of 3 meter. Okay, so this is the load point. Now let's assign the loads. So uniformly distributed load assigned to the selected beam. Assign. Yes, you can see this load is assigned in the x direction. Now next assign the nodal load. Okay, select the node cursor, select node number 6, assign. Okay, next concentrated force, select a beam cursor, selecting a beam. Yes, assign to selected beam, assign. Yes, now here you can see it will be applied in the upward direction. Why? Because we are not putting the negative sign. So here I am substituting that minus sign, change, close. So now this will be applied at a vertically. Okay, now in this way you can apply the loads over here, load values. Okay, so this will be 35 kilonewton per meter, then this will be 25 kilonewton, and here 15 kilonewton load is there applied. Now next job is the analysis and print. Select here all, add over here, then close. Now perform analysis, select the whole section, assign, sign, then go for the run analysis. Okay, so 0 errors, 0 warnings, done. Now let's go in the post processing mode. Okay, now you can select here the deflection view, press the control. Okay, so here in this way a beam is get or frame is get deflected. Okay, then you can also see the shear force diagram. So here this is the shear force diagram. The concentrated force is, I am applying a concentrated force, therefore this kind of option is appeared, but actually this will be the constant value. Okay, and now here again the concentrated or the nodal point load. Then next you check the bending moment diagram. Then here this is the shape of bending moment diagram. UDL, third degree as a fixed support, so here there is a bending moment value. Again here point load, right? So you can check the reactions at the support also, minus 124.825, then here minus 35.175. even in this, if you select any particular beam, if you are selecting here the displacements, right, and now if you are selecting a beam over here, so here the details related to that beam that will be get displayed over here, right? If I am selecting a beam number 3, then the details of load case 1 for beam number 3 that will be displayed over here. That's reactions are so and so, and moment is this minus 21.15. Then similarly for the next beam number 4 and then the beam number 5, sorry. Okay, even if you select the graph also, so selecting this beam you will get the graph of first, then the second, this will be the bending moment, this will be the shear force, and this will be the reflection or in x direction, then here number 3 and beam number. So in this way for frame also you can do the analysis. Only the thing is that here based on the direction of the load, when you are adding a load or when you are defining a load in this load case detail, then in that case you have to assign that directions x and y properly, so that loads will be get assigned properly to the view. Okay, similarly whatever the we have seen related to reports and all that, all those things that you can take a printout from this also. Okay, now Let's solve one more type of frame over here. Okay, let's solve this type of frame structure, single span frame, using the start row. So here you can see A, B, C, D, 3 points were there. The AC span will be of 5 meter, then BC will be of 2 meter, and CD will be of 3 meter. Now let's close this one. Let's take new one, plane, frame 2, go in the next. Okay, take the front view. Now I'm starting from here. Suppose the span will be of 5 meter, so initially it will be of 4 meter, then again 2, 3 and 4. Then this side CD is of 3 meter and here 1 meter, 1 meter. So here 1, 2 and 3. Okay, escape. Now close the view. I'm adding beam to the opposite x direction. So here -1, then height will be of 5, 0, then again further -2, height is of 5, 0, 0. Okay, now let's join this. Okay, escape. Now next job is general property, define. Take the cross section size 0.3 by 0.3, add over here, close, assign to view, so all the beams are get selected automatically. Then next go in the support section, create a support. So here fixed support I am creating, add one more, I am creating the pin support, add. So fixed support is provided at the D and at the A, and pin support is provided at the B. So assigning this, okay, assigning this fixed support, taking the node cursor at node 1, and this there is a fixed support, assign yes. Then pin support, use cursor to assign, selecting this node, assign yes. So here at this point there is a pin support. Now let's go in the load and definition. At this node point there is a load of 25 kilonewton, here there is a load of 35 kilonewton per meter, and this horizontal load of 10 kilonewton. Okay, so there are two nodal loads, 25 and 10, and one UDF. Okay, so let's start with that. Load case details, add load case 1, add over here, then close. In load case 1 add the load. Now nodal load of -25 kilonewton in x direction, add. Then another load is -10 kilonewton in x direction, add. Then there is a member load of -35 kilonewton per meter in y direction, add, close. So let's assign the load, considering -25, select the node, assign to selected node, assign yes. Then next another point, okay, that node I have deleted by mistaken, so we assign this load afterwards. Let's insert, okay, so okay, sorry, I have deleted this node point over here. So let's go in the geometry, put that node over here, that at a 0 at a height of 1 meter. Okay, now go in again, general, load case details, load case 1, fx, use node cursor, assign to selected node, assign yes. Okay, then uniformly distributed load of 35 kN per meter, select the beam cursor, select the beam, assign to selected beam, assign yes. Can reduce the size of rows and all. Now here can display the load values over here. Okay, so this is the modeling of the frame done. Now let's go in the analysis and build. Select over here, add, close, select the perform analysis, then assign, then go in the analysis, run analysis. Okay, 0 errors, 5 warnings, done. If there is a warning, there is no problem, but if there is an error, the output results are not get displayed. Go in the post processing mode, apply, okay. Now let's check first of all the shear force diagram. So here you can see the point load is there, you can scroll down the size. Okay, this is a bending moment diagram, and then this is a deflection curve. Right, now you can see the reactions also at 3 supports. Similarly, you can go over here, beam, then if you select on the beam, you will get the values of reactions and the bending moment values. Whichever the beam you select, you will get the values of those reactions and all. Right, so in this way you can analyze any frame given for its maximum bending moment as well as the shear force. Again you can plot the stress diagrams also for the same. Okay, now you can do the practice of analyzing such type of single bay frames. In the next video we discussed about analysis of multi-story frame. Okay,